Hello students, in the previous video we discussed about preparation of highly soluble salts of potassium and sodium. Now in this video we are going to see the soluble salts of other metals in the activity series, metals below sodium, that is calcium, magnesium, zinc, iron, etc. So keep watching. Method 2 for the preparation of salts. Now this method is for the salts of metals like calcium, magnesium, zinc, iron, lead and copper. Now the reactions involved are different kinds, 4 kinds of reaction. The first reaction is metal plus dilute acid will give salt plus hydrogen. We use this for magnesium, zinc and iron only these 3 metals. Okay, note carefully, this method involves different types of reaction. So for metal plus dilute acid cannot be used on other metals like copper and calcium. We cannot use. You can use it only on magnesium, zinc and iron. Okay. Right. Then we have metal oxide plus dilute acid. Metal oxide is a base plus acid neutralization. Salt plus water. Except this iron, because FeO is usually not available in the laboratory. Then metal hydroxide plus dilute acid. Salt plus water. Metal hydroxide is a base, so salt plus water will be formed. Again, except Fe, ferrous hydroxide or ferric hydroxide is not usually available in the laboratory, so it is not used on them, right? Metal carbonate plus dilute acid, that is salt plus water plus carbon dioxide. This can be used on all of them, right? So these are the 4 kinds of reactions. What are they? Metal plus acid, metal oxide plus acid, metal hydroxide plus acid and metal carbonate plus acid. Okay. So let us apply this on various salts now, how we can prepare. The list of salts. For calcium we have 2 soluble salts, calcium chloride and calcium nitrate. Magnesium chloride and magnesium nitrate and magnesium sulfate, 3 soluble salts. Zinc we have 3 soluble salts, the chloride, nitrate and sulfate. For iron we have ferrous chloride and ferrous sulfate. And then for lead, only soluble salt is lead nitrate. Copper we have the chloride, nitrate and sulfate, right? Now the reactions involved are neutralization in some cases, and some cases it is displacement. Okay, so let's start with the first salt, calcium chloride. Calcium chloride, as we have seen, calcium we have the metal plus acid method is not available. We have metal oxide plus acid, metal oxide plus acid, hydrochloric acid for chloride ion. Calcium ions we will get from calcium oxide or metal hydroxide, calcium hydroxide or calcium carbonate. So these 3 for the calcium ions, and for the chloride ion we have hydrochloric acid. So there are 3 equations possible, CaO plus HCl. Calcium is a di-positive ion, divalent ion, so we need 2 HCl, 2 hydrogen ions required to replace it. So we have CaCl2, metal oxide plus acid gives salt plus water, H2O. So you got a calcium chloride. This is the salt we require. Second method is for metal hydroxide. Calcium hydroxide is a base plus acid, HCl. Again calcium divalent, 2 HCl is required. You get CaCl2. Plus there are 2 OH groups, so there will be 2 water molecules, 2H2O, right? Then we have calcium carbonate, CaCO3 plus HCl. Calcium divalent, 2 HCl is required. CaCl2 will be produced. Carbonate plus acid will be salt plus water plus carbon dioxide, which we know already. Yes, so you get salt, water and carbon dioxide. So all the 3 reactions will give us calcium chloride. The solution on evaporation will give you the salt. Okay. Then let's go to the next salt of calcium, that is calcium nitrate. Calcium nitrate, the nitrate part will be obtained from nitric acid, HNO3. For calcium, as we have seen, we have metal oxide, calcium oxide, we have metal hydroxide, calcium hydroxide, and we have metal carbonate, CaCO3. Okay, so let's have 3 reactions. CaO plus HNO3, nitric acid, will give divalent 2HNO3. So CaNO3 whole twice, yes, plus H2O, water, right? Then we have calcium hydroxide, CaOH whole twice plus 2HNO3 will give calcium nitrate, CaNO3 whole twice plus 2H2O, because there are 2 OH groups here, so 2H2O, right? Then we have metal carbonate, calcium carbonate plus acid, HNO3. It will be 2HNO3 always because of divalent nature of calcium. right? So you have calcium nitrate CaNO3 whole twice, and water and carbon dioxide, because it's a carbonate plus acid. Okay. Now we have the next salt called magnesium. Okay, magnesium chloride. We have the chloride part will come from hydrochloric acid HCl, right? And then we have the magnesium part. Magnesium we can take metal plus acid, or metal oxide plus acid, or metal hydroxide plus acid, OH whole twice, or metal carbonate plus acid. So there are 4 possibilities for the magnesium, and for chloride ion it is HCl. Okay, so you can write 4 equations: Mg plus HCl, 2 HCl because magnesium is divalent, plus 2 valency. So MgCl2 plus H2, hydrogen. Metal plus acid gives salt plus hydrogen. Hydrogen is liberated, active metal it is. Magnesium oxide plus HCl, 2 HCl. Metal oxide is a base. Base plus acid is salt plus water, H2O. It is balanced. Then we have metal hydroxide, which is also base plus acid, 2 HCl required. You get magnesium chloride MgCl2 plus 2 H2O. There are 2 OH groups, 2 H2O, right? Then we have metal carbonate, magnesium carbonate plus HCl, 2 HCl required again. You have salt plus water plus carbon dioxide, right? Then you have magnesium nitrate, the next salt. Here again we will not use metal plus acid with the nitric acid, because nitric acid is an oxidizing agent. So here metal plus acid method is not possible. Magnesium oxide is possible, magnesium hydroxide is possible, magnesium carbonate is possible. Only 3 equations here, right? So first reaction is MgO plus HNO3, 2 HNO3 required. Magnesium is divalent, so MgNO3 whole twice plus H2O, right? Then we have magnesium hydroxide, MgOH whole twice plus HNO3. As we know, 2 HNO3 required. So we get magnesium nitrate, MgNO3 whole twice plus 2 H2O. There are 2 H groups, so there will be 2 H2O. Then we have metal carbonate, MgCO3 plus HNO3. Again 2 HNO3 required. You have magnesium nitrate, MgNO3 whole twice plus water plus carbon dioxide, salt plus water plus carbon dioxide. So magnesium salt, magnesium nitrate is prepared by this method. Now we will go to the next magnesium salt, which is magnesium sulfate. Magnesium sulfate, here we have 4 reactions possible. The sulfate part is from sulfuric acid H2SO4, right? And metal plus acid is possible, metal oxide plus acid possible, metal hydroxide plus acid possible, and metal carbonate plus acid possible. 4 reactions possible. So we have first reaction Mg plus H2SO4 will give you MgSO4 plus hydrogen gas. Okay, hydrogen gas evolved. Then we have the next one, metal oxide plus sulfuric acid. Now sulfuric acid is dibasic, 2 hydrogen, so 1 magnesium, 2 hydrogen, it balances easily, right? So MgSO4 plus H2O, water will be base, metal oxide is base plus acid, right? Now MgOH whole twice plus H2SO4 will give MgSO4 plus water. 2 OH groups are there, 2 H2O, it is balanced. Now carbonate, MgCO3 plus H2SO4. MgCO3, carbonate plus acid will give salt, MgSO4 plus water and carbon dioxide. Done. So 4 equations for magnesium sulfate. Now we have zinc chloride. Zinc, again 4 methods possible: metal, metal oxide, metal hydroxide and metal carbonate. plus acid is hydrochloric acid, right? Because we need the chloride. So 4 equations possible. Zn plus HCl. Now we need 2 HCl because zinc is divalent, 2 hydrogens required. So ZnCl2 plus hydrogen, then ZnO plus HCl, 2 HCl, ZnCl2 plus H2O, water is produced because it is base. ZnOH whole twice, zinc hydroxide plus HCl, 2 HCl, so zinc chloride plus water, 2 molecules of water. Then we have zinc carbonate plus acid, again 2 molecules of acid. You get zinc chloride plus water and carbon dioxide, right? So zinc salt is prepared. So the next zinc salt we have is zinc nitrate. How do we prepare? You have zinc oxide, metal is not used with nitric acid, zinc hydroxide and zinc carbonate, 3 only. Okay, this side we have nitric acid. Okay, so let's write zinc oxide plus HNO3, 2 HNO3. Yes, so what you get? Zinc nitrate, ZnNO3 whole twice plus H2O, water. Then zinc hydroxide plus HNO3, again 2 HNO3. You get zinc nitrate, ZnNO3 whole twice plus 2 H2O. There are 2 H groups, 2 H2O. Then zinc carbonate, carbonate plus acid, 2 HNO3, right? Salt plus water plus carbon dioxide. Okay, ZnNO3 whole twice plus water and CO2, right? So this is done. Now let us take the next salt, zinc sulfate. Here we have 4 options: metal plus acid, metal oxide plus acid, yes, metal hydroxide, acid is same, and metal carbonate, zinc carbonate plus acid, right? 4 equations possible. So we have Zn plus H2. So for the first reaction, what you have? Zinc sulfate plus H2. Sulfuric acid is dibasic, 2 hydrogens and 2 plus plus ions of zinc. Okay, zinc oxide plus H2SO4 will give you zinc sulfate plus H2O. Then zinc hydroxide plus H2SO4. Again you get zinc sulfate plus 2 H2O. There are 2 OH groups, 2 H2O. Zinc carbonate, ZnCO3 plus H2SO4. Carbonate plus acid, salt, zinc sulfate plus water plus carbon dioxide, right? Very simple. Now we have the next salt, salt of iron. Iron salt is ferrous chloride, FeCl2. So it can be metal or we can have metal carbonate. Oxide and hydroxide are usually not available. Even carbonate is rare. So HCl. Okay. So Fe plus 2HCl. Divalent metal, 2HCl is required. FeCl2 plus H2. Hydrogen gas is evolved. Then FeCO3, this is also rare, usually not available. Now HCl, if you use 2HCl will be there. You get FeCl2 plus water and carbon dioxide. This also is very rare, not usually used, right? And then we have the next salt of iron, that is ferrous sulfate, iron 2 sulfate. Iron is in +2 state here. FeSO4. So here we have all 4 the 2 methods, Fe and H2SO4, and also FeCO3, which is again usually not used. We can ignore this. So only one reaction, Fe plus H2SO4. You have FeSO4, salt plus hydrogen. Sulfuric acid is divalent, so it balances on its own. Then we have the next salt is lead nitrate. Lead, Pb++ ion, NO3- ion. So HNO3 for nitrate ions. Here we have metal plus acid is not used. Metal oxide is used. metal hydroxide is used and metal carbonate is used. So 3 equations possible. So let's write PbO plus 2HNO3. Lead is divalent, right? So PbNO3 whole twice plus H2O, water. PbOH whole twice, if you take the hydroxide, again 2HNO3 is required. What you get is PbNO3 whole twice, lead nitrate plus 2H2O. 2 OH groups are there. Lead carbonate, PbCO3 plus HNO3. 2HNO3 will give you PbNO3 whole twice plus H2O plus CO2, right? So these are the ways of getting lead nitrate. Then copper chloride, CuCl2. Here metal plus acid is not there. Metal oxide is there. Metal hydroxide is there. And metal carbonate is there. Plus the acid is HCl. Okay. So 3 equations, CuO plus 2HCl. Copper is divalent. CuCl2 plus H2O. And CuOH whole twice plus 2HCl again. You get CuCl2 plus 2H2O. Yes. CuCO3 plus 2HCl. You will get CuCl2 plus H2O and CO2, right? So 3 equations for copper chloride. Now we have copper nitrate. Copper nitrate, again metal oxide, metal hydroxide and metal carbonate only. 3 methods. HNO3, nitric acid is here. So you have CuO plus 2HNO3, copper divalent as I already mentioned. So CuNO3 whole twice plus H2O, right? CuOH whole twice plus 2HNO3, nitric acid will give CuNO3 whole twice plus 2H2O, 2 molecules of water. Then we have copper carbonate, CuCO3 plus 2HNO3. Here what you get? CuNO3 whole twice copper nitrate salt plus water and carbon dioxide, right? Now we have the last salt here, that is copper sulfate. Copper sulfate, as you know, CuO is available, CuOH whole twice is available, CO3, copper carbonate is available, and sulfuric acid is used, right, for sulfate. So let's write 3 equations. CuO plus H2SO4. What you get? CuSO4, copper sulfate, plus H2O, water, and CuOH whole twice, plus H2SO4, sulfuric acid. Here you have 2 OH groups, so copper sulfate plus 2 molecules of water, 2H2O. Then we take the carbonate plus acid, H2SO4, salt plus water plus carbon dioxide. So you have CuSO4 salt plus water H2O plus carbon dioxide CO2. That's it. So if you know techniques, you can very technically move and the salts can be easily prepared. So I hope students you understood how we can prepare the various salts of calcium, magnesium, zinc, lead, copper, etc. So you can watch the video again if you didn't get it well. So, and if you have queries, you can please write it in the comment. Please like and subscribe the channel. In the next video, I will describe about the insoluble salts, how we can prepare insoluble salts. Thank you.